Right, in our fourth lesson, we're going to go over some more postulates and theorems. So again, some of this stuff might seem like, well, duh, but it is just some things we have to go over to make sure that we know everything to use. So first thing we're going to look at is called the parts to whole theorem. You don't necessarily have to draw these. I would draw at least one of them to kind of make sense. Basically, the parts to whole theorem says the whole of something is equal to the sum of its parts, which is just a fancy way of saying these two pieces will add up to make the whole piece. So if you have a line segment going A to C, and it's chopped up by this point B, then this length A to B plus this length B to C equals the whole length A to C. So again, it should be kind of an oh duh situation, but it's just a fancy way of spelling it out for us. Similarly, if we look at these angles here, a large angle ADC, it's chopped up by this ray DB. Now since this cuts it, not necessarily exactly in half, but it cuts it somewhere, it means there's actually three different angles we're looking at. One small one here, ADB, one small one here, BDC, and one large one, ADC. So, again, what the parts to whole theorem says is, even though we don't know the measure of any of these angles, we know that the measure of angle ADB plus the measure of BDC equals the whole measure of angle ADC. So this little m in front, again, just says that it's the measure. Whatever it comes out to, if this was 30 degrees and 20 degrees, this would have to be a 50-degree angle. This plus this has to equal this. Just a fancy way of saying it. The next one says congruent supplements theorem. Again, this is very similar to a transitive property. It says if two angles are supplementary to the same angle, then they're congruent to each other. So if angle A is supplementary to angle B, and angle C is also supplementary to angle B, then angle A has to be congruent to angle C. So it's a lot of writing there, it's a lot of words, but let's just pick this apart and use actual numbers. 100 degrees is going to be our A. So if A is supplementary to B, B has to be 80. Right? 100 plus 80 equals 180. Supplementary. C is also supplementary to B. We already knew B was not 100, was 80 degrees. So if C is supplementary to B, C also has to be 100. Now notice, C is 100, A is 100, A has to be congruent to C. They have to be the same measure. It's just, again, kind of a fancy way of saying it. So instead of having to go through all of that work to explain yourself, you can just use the congruent supplements theorem to say that A and C are congruent to each other. Congruent complements theorem is the same exact idea, only you're using complementary. If two angles are complementary to the same angle, then they're congruent to each other. So if angle A is complementary to B and angle C is complementary to B, then angle A has to be congruent to C. A and C have to be the same measure. This last piece is not actually a theorem, it's more of just a definition, a bisector. Either an angle bisector or a segment bisector. Now, a bisector is a line, a ray, or a segment that would cut the angle or the segment into two congruent angles or congruent segments. So, if I have, let's say, segment AB. Now, I don't know exactly how long this is, but I'm going to cut it exactly in half, like so. Now, this side, I'm going to use 2 tick marks to show that this side is exactly the same length as that side. This black line, maybe we'll call it line L, kind of a cursive fancy L, this line L bisect segment AB, meaning it cuts it exactly in half. Okay, that means these two are the same length as each other, which means we should probably put a point right there and call it maybe C. AC is congruent to BC. They're the same exact length because they got cut exactly in half. Now to go along with that bisector then, at least for this segment, C you would also call the midpoint. Now we'll get to midpoint in just a little bit, but that's basically what it's saying. It's the halfway mark. Now if you want to look at that as an angle, let's say we have kind of a larger angle here, A, B, C. Now if we bisect it with a ray BD, then we can know that angle ABD, this one, is congruent to angle DBC. These have to be the same because it cut them exactly in half. So that's really all a bisector means. It means to just cut them in half. For these next two, you need to pretend that you know the points x1, y1. So this is one point, and another point, x2, y2. This is another one. And I'll use an example to show you what this means. So say we have 2 points on a coordinate grid. If you want to know the distance between these 2 points, here is the formula for it. Now this formula comes from the Pythagorean theorem, and we won't necessarily look at that right now to show what it is, but just know that that's where it comes from. You can go from this point to this point in this distance. The midpoint formula, and remember the midpoint separates a segment into 2 congruent segments, or 2 segments that have the same distance. To find the midpoint of these 2 points, you're basically just taking the average x value and the average y value, and that'll be your new point. So let's go over what this means. You might want to write this example down in your notes. So draw a quick grid. It doesn't need to be exact, but we're going to use the distance and midpoint example. We're going to use the point 4, 6 in red. So over 4 up 6, right here is that point. And in purple, we're going to go 8, 2. So over 8 up 2, there is that point. To find the distance between these two, we plug it into this formula. So where we saw x sub 2, that was our second x value, that's right here, 8. X sub 1, our first x value right here is 4. Y sub 2 is right here. Y sub 1 is right here. So we just replaced all of these pieces with the actual values from the points that were given. Now you just go through and solve it algebraically. 8 minus 4 is 4. 2 minus 6 is negative 4. 4 squared is 16. Negative 4 squared squared becomes 16 as well. 16 plus 16 is going to be 32. So the distance between these two is the square root of 32. Now there isn't an exact square root of 32, so we're just going to leave it like this for now. But that's the distance. If you wanted to measure between these two, it would be the square root of 32. If we wanted to find the midpoint, the exact middle point between them, we're just finding the average values. So that second x value was 8. That first x value was 4. The second y value was 2. The first y value was 6. So here and here. Simplify it. 8 plus 4 is 12. 2 plus 6 is 8. 12 over 2 is 6. 8 over 2 is 4. So the midpoint must be at 6, 4. Now we can kind of test that and see if that's actually true. 6, 4. That's where we think the midpoint should be. Now if you look at that, going from this point to this point, does this look like the halfway point? Yep. Definitely that does look like that should be the middle spot for those 2 points. So that's how you find the distance and the midpoint. So we're going to come back to example 1 at the end. Right now, I want to go over a few of the other examples. First, we're going to go over example 2. If we are given that segment BD bisects angle ABC. What conclusion can we draw? All they told us is that this segment bisects this angle. So we don't necessarily know anything about this segment or this segment. Really, all that gave us was angle ABD, this one here, is congruent to DBC. These two are the same angle. Suppose we can draw it in if we want. All that really gave us is something that looks like this. Those two angles are the same because they were bisected. Let's look at 3. Given two intersecting lines, what conclusion can we make? This one will have a little bit more. If these two lines intersect each other, because of vertical angles, we know that 1 and 2 are congruent. I'll use a different color. 4 and 3 are also congruent. That one got a little bit away from me. But we know that those ones have to be congruent because of vertical angles, our vertical angle theorem. Now as well, if this is a straight line, then 1 and 3 are a linear pair, which means the measure of angle 1 plus the measure of angle 3 has to be 180. So 1 and 3, 1 and 4, 2 and 3, 2 and 4. So we got all of this information just by looking at two lines that intersect. Now again, we haven't necessarily been given any measure, but we can just imply that all of this is true. When they finally give us, like say this was 70 degrees, then we can figure out everything else. Given that angle 1 and angle 2 are complementary, what is our conclusion? Well, really, all of our conclusion is just the measure of angle 1 plus the measure of angle 2 is 90 degrees. I guess you could also say the larger angle is in fact a right angle. Well, that's really all we can say. Given that segment BD bisects segment AC. So this was now a segment bisector, not an angle bisector. So what things can we conclude? Well, we can conclude that AD is congruent to DC. So I'm going to put tick marks AD, DC. We also know that this length, A to D, plus this length, D to C, has to equal A to C. That was our parts to whole theorem. So let's say they gave us that this one was 4. Well, because of this, we would know that this is also 4, and we would know that in total, that makes 8. Okay, they haven't given us that, but if they did, we'd be able to figure that out. We also know that by definition, D, this point, is the midpoint of AC. Again, that's just kind of a nitpicky thing. It's just saying little pieces or little definitions, stuff we can figure out from this given. Number 6, given that E is the midpoint of AB. This is a midpoint. What can we conclude? Well, we can get a few things out of that. AE is congruent to EB. This length, oops, I'm going to do this in red. This length is the same as this length. If this was 2 centimeters, this would also be 2 centimeters. A to E plus E to B must be A to B. Again, just a parts to whole theorem. Segment E, or CE, bisects AB. This segment is a segment bisector. Same thing, DE bisects AB. This is a segment bisector because it also cuts that. Goes through the midpoint, so it must be a segment bisector. Again, these are just kind of nitpicky things, but you got to be thinking about all the different things that you can figure out from just a little bit of given information. Number 7, given that diagonal AC bisects diagonal BD. So this one cuts this one in half. What can we conclude? Well, there's a few things we can conclude. First off, we know that E is by definition the midpoint of DB. We also know then that D to E is congruent to E to B. That has to be the same length. We also know then that D to E plus E to B has to be E to B. Again, just kind of nitpicky. Well, because these two are bisecting each other or intersecting, then all the things we got from, which number was that? From number 3, all of this stuff must hold true on this one. Angle AEB is congruent to DEC. Angle AED must be congruent to BEC. This and this are the same. This and this are the same. And this one plus this one is 180. This one and this one, this one and this one, this one and this one. Those must all add up to 180 because they're linear pairs. Now we're going to come full circle back to that number 1. The reason I do that is just to kind of show you or build up to kind of the why on some of these things. So given that CD is perpendicular to AB, all we know that it's perpendicular to AB. What can we conclude? Well, we know then that ADC, so that's this angle here, and CDB are both right angles. Okay, this technically tells us this one and this one are both right angles, meaning that this measure is 90 and this measure is 90. Again, just kind of nitpicky, getting at all of the specifics about it. That also tells us that ADC is congruent to CDE. Right? They're both 90, so they have to be congruent to each other. Well, technically then, if these two are the same, think about this as a vertex, this as a ray, and this as a ray. Technically then, CD is an angle bisector. CD is an angle bisector to ADB because it cuts this exactly in half, 90, 90. And then we also know that the measure of ADC plus measure of CDB has to equal 180 because they're on a straight line, so they are a linear pair. A lot of things you can get from just a little bit of information. It seems tedious and nitpicky, but you need to be able to pick out these things.